Hello. In this video we're going to continue to talk about solving a system of equations, but in this case we're going to use a new method called elimination. The elimination method is sometimes called the addition method, specifically because we use the operation of addition to do our solving. So if you look at the two equations we have here in our example, 3x plus y equals 7, and 5x minus y equals negative 15. If we add these together right now, so I've got my x's lined up, my y's lined up, my equal signs lined up, and my numbers at the end lined up. If we add right away, we'll notice, well, I can do 3x plus 5x, that gets me 8x. And I can do y plus negative y, and those cancel, and then that's going to equal, well, 7 minus 15, 7 plus negative 15 is negative 8. And so I'm in a situation where I'm ready to just go ahead and solve for x. So I'm going to divide both sides by 8. And we notice that x is equal to negative 1. Well, I have my value for x. I just need to go back and find my value for y. So I can pick either equation and plug negative 1 in. It doesn't matter. So I'll just choose the top. And instead of x, I'll put negative 1, since I know that's the value of x that I just found. Still plus y, still equals 7. And we solve. So 3 times negative 1 is negative 3. Still plus y equals 7. Now we'll add 3 on both sides, so y is equal to 10. So our ordered pair should be negative 1 comma 10. We can check our answer by using the bottom equation and plugging these numbers in again and seeing if it's true for both. If it's true again, then we know we've done a correct solving job. So 5 times negative 1 minus 10 equals negative 15. 5 times negative 1 is negative 5. Still minus 10. Is that actually equal to negative 15? Yes, it is. So this must indeed be our solution. Let's look at another one. In this example, we're still asked to solve by elimination. But if you notice, if we add right away, I'm going to have to take an x plus an x, and that's not going to cancel. That'll get me 2x. In the previous example, when we added, our y values went away. And that's what we want. We want our y, one of our variables to disappear after doing our addition. So what if instead of addition, and I'll use my undo button here, what if instead of addition we use subtraction? Well, that means I'm subtracting the entire bottom equation from the top. And so what that looks like, I'm going to still have x minus 6y equals 12, but the bottom I have to show I'm subtracting. So I do a minus x, and then minus the negative 3y, which makes it plus 3y, and that's equal to minus a negative 9, or plus 9. And now I can add down my columns. And so negative x, or rather x plus negative x cancels, and so we get nothing there. Negative 6y plus 3y is negative 3y, and that's equal to 12 plus 9 is 21. So when we solve for y, we divide both sides by negative 3. We find that y is negative 7. So once again, let's plug this in, one of our values, in order to find the x value, one of our equations, excuse me. So I'll use the bottom equation this time. And so I have x minus 3 times, and instead of y we have negative 7 now, equals negative 9. And so we get x plus 21, negative 3 times negative 7, equals negative 9. And getting x alone, we'll subtract 21 And so x is equal to negative 9 minus 21 more is negative 30. So our ordered pair looks like it's going to be negative 30 comma negative 7. And let's check. If I use my top equation and I plug negative 30 for x and negative 7 for y, we should get a true statement. So we'll have negative 30 minus 6 times negative 7 equals 12. And so negative 30, negative 6 times negative 7 is a plus 42. And does that equal 12? And it sure does. So there's our final, our ordered pair here, and we are done.